Hello, 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 hello. And welcome to this lesson about distribution graphs. This is something you definitely need to know for your exam. So let's just crack on. We're going to cover what normal and skewed distributions look like, their characteristics, and so you can interpret them in terms of what they mean regarding your data. That's the purpose of today's lesson. Shall we crack on? Oh, yes, let's. So, in terms of what we mean by distributions, a distribution graph shows you how data is spread out. We tend to use them in large data sets, so when we've got a lot of information. With much smaller data sets, you might use a histogram to show similar information. So, basically, it tells you how much of your data is at the higher end, how much at the lower end, or is your data clustered roughly in the middle? This all relates to the stuff we were doing on the measures of central tendency, the mean, the median, and the mode. So hopefully you can remember all of that. So you need to know how these distribution graphs work. So I'm going to show you a few examples, talk about what you might be asked to do in the exam, how you might be asked to either interpret one or to sketch one. Important thing to bear in mind is distributions vary. We tend to put them into three categories: normal, and then two types of skewed distribution. So we'll start with the normal distribution. And again, this is important because if we assume our data is normally distributed, when you do statistics next year, your choice of statistical test will depend on whether you've got a normal distribution or not. So a normal distribution creates a bell curve like this. And that is showing where you can see the mean, median, and mode there are all in the middle of our graph. And then we see, so this will be frequency on the y-axis here, and then whatever you're measuring along the x-axis. So in this case, if we take something with a normal distribution, such as the life of a light bulb, the mean life of a light bulb might be, let's say, 1 year. And the median life and the mode will all be 1 year. Most light bulbs will last 1 year. As you will have some light bulbs down this end with much lower frequency that may only last 6 months. A few light bulbs just pop. And then you'll have some at this end that will last a year and a half. But most will last 1 year. And when you put all of your data out, the mean would be 1 year in the median. And that's what we call a normal distribution. Now, probably the most famous example that you could give of a normal distribution would be IQ scores. And we've talked about this briefly in a lesson before. If you plot IQ scores onto a graph, you end up with one of these bell curves. And that's because IQ tests are designed to create a normal distribution. The average IQ score is 100, and they are set to keep that. And most people will get 100. So the mode is 100, the mean is 100, and therefore the median is also 100. And then as your IQ scores drop, you find fewer and fewer, this would be frequency again, fewer and fewer scores getting, so 70 there, much less than people getting 100. And likewise 130 here, much less. And IQ scores are designed then that 15 above or 15 below, 68% of everybody fall within that range. And that's actually one standard deviation from the mean. And then two standard deviations take into account 95%, 95.8, round it up to 96% of our population fall within that category. So it's very, very rare, and I mentioned this before, if you end up with an IQ score of less than 70, you fall within the 2%, a 2% statistically infrequent group. which you can relate to your abnormality definitions. You would have an abnormally low IQ if you were below 70, what they used to charmingly refer to as a moron. And if you had an IQ of over 130, you're statistically abnormal. You'd have an abnormally high IQ. But IQ always falls on this bell curve with a normal distribution. Magically, this isn't just true of IQ. Given any set of normally distributed data, 68% of whatever you're measuring will fall within one standard deviation like that. Okay, so that's normal distribution. Now, I was going back through the tests I've been setting you over the last couple of weeks and looking at the results, because that's why I set you tests, so I can see how you're doing. And out of all the tests, the thing that came closest to being normally distributed, now obviously this is in a much smaller data set, so it's drawn as a histogram. Do you remember the multiple choice test I gave you at the end of social influence? Well, when I look back at how we did as a cohort, as like all three groups on that social influence quiz, you will see that most people scored 38 points on that test. And actually, the median score was also 38, and the mean was 38.2, which would create what would be close enough to a normal distribution for that test. See, there's some anomalous score there. That means it's not properly a normal distribution. Okay, so that's normal distribution. So I'm going to give you time in a bit to write some of this stuff down. So don't fret right at the moment. You can just listen, and then the beauty of a video is just zip it back if you need to listen again. So we're going to look at skewed distributions. Oh, goodness me, I can't speak. In a skewed distribution, you don't end up with a bell curve that is symmetrical. What you end up with is it skews to either the right or the left. And it's important that you know which is which and what that means. So if it skews like this to the left with a long tail down to the right, that's what we call a positive distribution. What you've ended up with basically is most people's scores are lower than the mean. And we tend to see this if a test is particularly difficult. So if I was to set you a test and most people scored, let's say, 22, and most people's scores were around that area, then you might end up with the mode being 22, the median being 23. But some people on the test will score much, much higher. Therefore, the mean is dragged out to the right here. And we end up with a skew with a long tail going down to the right. And as I say, this tends to happen when you have a difficult test or what you're measuring. Most people actually get below the mean, but a significant number of, let's call them freaks, score very highly, and that skews the mean out, and you end up with what we would call a positive distribution. A negative distribution is the same in reverse. This time the long tail is on the left side. And again, using a test example, if I set you a test which was easy, most people would get a high score, and your mode and your median would be at the high end. But some people, maybe they weren't paying attention, maybe they didn't click the right buttons, maybe they just had a bad day, got a really, really low score, and that will drag the mean out much, much lower than the mode, and this creates the long tail down on the left. So an easy test might create a negatively skewed distribution. I'll give you an example again from the tests I've been setting you. This was the test I gave you on descriptive statistics last week or the week before. The mean, median, mode, all of that sort of stuff, range and standard deviation. Here you can see the mode in this test was 28. most people got 28 out of 30. I clearly made the test too easy. The median score was 27. The mean was 26. So although they are quite close together, we would end up with this skew down to the left here, a negative skew, the long tail going down there. And we can see a number of lower scores of what has affected the mean there. So a way you can try and remember all of this information about obviously a normal distribution is a bell curve. If you look down at your feet, now obviously you're going to have to try and remember this, because I'm not suggesting in the exam you take your shoes and socks off and start staring at your feet. But if you look at your left foot, you've got your big toe there, and then it goes woo down to your little toe, the long tail down to the left. Left foot, negative skew, the E there. Likewise, if you look at your right foot, you've got your mode there, and going wee down to the mean at that end. The long tail down to the right. Your right foot is a positive skew, and the I there, first vowel. Do you see? Magic. So if you try and remember that as a way of remembering which one's negative and which one's positive, that might help. Okay, in your handouts, your text, you will find a matching activity on the top of page 51. So this might be an opportunity for you to pause the video here, dig out your text, have a go at the matching activity. If you need to zip back and listen again, do that, and then we will move on. Pause now. Okay, I'm assuming you've paused and you've done all that, so we're going to move on. Right, so distributions. This is what we've been talking about. If you need to draw a distribution, or just to, if they give you the mean, median, and mode, and you need to say what kind of distribution that will create, that's what we're going to look at now. They would probably simply just give you a mode, a median, and a mean, and ask you what sort of distribution this might create. So if the mean, median, and mode are all the same or roughly the same, you can assume that your data will have a normal distribution. And if you're asked to sketch a normal distribution, it would look like this. This is your classic bell curve, like you'd find in IQ, light bulbs, that kind of thing. Now, if your mode is the smallest number, then your median, and then your mean is the biggest, your data is going to have a positive skew. So left to right, it would go mode, median, mean. So you're going to end up with a long tail to the right. Likewise, reverse it. If your mean is the lowest score, and then your median, and then your mode, you're going to have a long tail to the left, which is going to be a negative skew. So if they ask you in the exam what sort of distribution your data is going to have, first step, you're going to need to order the data and have a look. Is the mode the smallest or the mean? So mode, median, mean, positive. Mean, median, mode, negative. So as I say, order the measures of central tendency and then work out what is your distribution. So here we go. What sort of distribution would the following have? You've got a median of 22, a mean of 19, and a mode of 27. Well, let's put them in order. So mean 19 goes first, median 22, mode 27. Mean 19, median 22. Hold on a second. It's a negative skew. See what? Okay, so I'm going to do a worked example. So for this, any bit of paper will do. You don't need to use graph paper, but I'm going to just practice what might happen if you're asked to draw out one of these bad boys in an exam. Researchers gave people a questionnaire, and the questionnaire was designed to measure the amount of daily hassles they'd experienced. Daily hassles are things like losing your keys, getting stuck in traffic, minor stresses. The median daily hassle score they got was 67, the mode was 78, and the mean was 65. And in the exam, they might ask you to draw a graph to show the likely distribution for the scores in this study. So let's work through this with our bits of paper. Pause the video if you need to go and get a bit of paper and a pencil, maybe a ruler. So step one, we need to rearrange the data from the lowest to the highest. So it would now look like this. The mean is 65, the median 67, the mode 78. We already know, or we can work out from this, what that skew is likely to be. Come on, have a think. Mean, median, mode. It's going to have a negative skew, isn't it? The big tail's going to go down to the left. Step two is we draw out our axes. Now, as I said, in a distribution graph, the frequency is always on the y-axis. That's the one that goes up. And whatever you're measuring, in this case, the score on the test, is always on the x-axis. But that could be time, days, IQ, whatever you're measuring will go along the bottom axis. Okay, so we draw that out. Now, we pick a scale that is going to be sensible. This scale, not sensible. But we would pick one based on the numbers that we've been given. And then step three, we're going to sketch the distribution. So we know it's negatively skewed, so it's going to have a long tail to the left. So we start by marking on the mode. So on here on the frequency, we go, mode there. That's always going to be the highest point of our distribution curve. Then we mark on the median, which we know is less than the mode. And then finally, we mark on the mean. And we got how far away the mean is from the median. The mode will depend on your data set. Obviously, in the example we gave, I just gave you, I think the mean was 65, in which case it would be much, much closer to the median than on this Google image. But, you know, I wasn't going to draw the graph for you. Should have done, really. Okay, so again, time to pause the video. And what I want you to do is to create a cue card or some sort of revision material for each type of distribution. So you need one for normal, one for positively skewed, one for negatively skewed. Use your text to help you. Go back through the video. Maybe give the old feet example. Left, negative. Right, positive. Yeah, I'll shut up now. Move on. Back at our data. The mean was much higher, 29. This was 19 and 20. Creating a positively skewed distribution. The long tail down to the right. Okay, have a go at this one. Pause the video. So participants in a memory study were tested on their recall of 15 words. The mean number of words recalled was 10, the median was 11, the mode was 13. And you have to say, what type of distribution does that have? In the second question, Anna is studying the relationship between IQ and gender roles. She gives 25 participants an IQ test. The participants' scores were normally distributed. So sketch a distribution curve for Anna's results. Pause, do it, or look at the answers. So in the questions you just had, the answer to the first one is it would have a negatively skewed distribution. That's because the mode was higher than the mean. And if you sketched Anna's IQ results, you should have frequency on the left, always up there on the y-axis, IQ, which is the thing you're measuring, the score on the x-axis, and then a normal distribution bell curve. Okay. The psychologist decides to modify the memory test so it would produce a more normal distribution. How might he achieve this? Ooh, normal distribution graph, and that would achieve a mark as well. Again, it doesn't have to be 100% accurate, just to show that you know what normal distribution looks like. Okay, hopefully that makes sense along with what's in the text. If it doesn't, let me know. And next lesson, we will have a look at some exam questions, or maybe just do a bit of crazy revision. Let's do some crazy revision. All right, see you later. Bye.